Previously, we've talked about domains of algebraic expressions, but now that we're talking about functions, I think it's probably important, probably beneficial to revisit this and talk about it again. When we're talking about domains, what we're saying is that in some cases, there are particular values of x that we cannot allow to be used in a function because, well, there's just some things in mathematics that you cannot do. For one, you can never divide by zero, and so we have to make sure that if we have a function with a denominator, we have to make sure that we restrict the values of x so that that denominator will never be equal to zero. The second one, and I'll give an example of this as well, is that whenever we have an equation or a function that involves an even root, a square root or a fourth root, we have to be sure that we never are going to take the even root of a negative number. Okay? Let's get that down. If you have a third root or a fifth root, it's not an issue. But if you have a square root or a fourth root, any even root, you've got to be sure that you're not trying to take the even root of a negative number. So we've seen some stuff similar to this previously, but it doesn't hurt to look at a couple other examples. Let's suppose we have a function that maps the input of x to 1 over 3x plus 6. Well, here's the case of the denominator. We've got to make sure that 3x plus 6 is never equal to 0. So we're going to subtract 6 from both sides, and we're going to divide by 3, and so we get negative 2. So we've got to be sure that in the domain of this particular function, we've got to make sure that x is never equal to negative 2. Alright? Got to be sure that the denominator can never be equal to 0. Let's look at an example that involves an even root. Let's suppose that we have square root of 7 minus 3x. That's an even root, so we've got to make sure that what's underneath the radical is always greater than or equal to 0. So we'll say 7 minus 3x. That can't be negative, so it's got to be greater than or equal to 0. If we subtract 7 from both sides, we get 3x greater than or equal to negative 7. If we divide both sides by negative 3 on both, we get x. And on the right side, we're going to get negative 7 divided by negative 3, or just 7/3. Now, do you guys remember what happens to this inequality when you divide by a negative? I hope you do. Anytime you divide or multiply by a negative when solving an inequality, you have to reverse that inequality. So instead of being a greater than or equal to, it has to be less than or equal to. Here's a real easy reminder of why it is that you must reverse the inequality when multiplying by or dividing by negative on both sides. You all know that 8 is greater than 5, right? Obviously. Well, now if we multiply both sides by negative, so that this is negative 8 and this is negative 5, is negative 8 greater than negative 5? Well, no. It's actually, negative 8 is to the left of, on the number line, it's to the left of negative 5. So, see, we've multiplied both sides by negative, that reverses that inequality. Anyway, that's just a little side note to help you remember that whenever you're multiplying or dividing by a negative, be sure to reverse that inequality. So, back to domain. We have a function that's the square root of 7 minus 3x. What we're seeing in this case is in order for this to never be negative, because we can never take the even root of a negative number, we have to be sure that x is less than or equal to 7/3. And so we can say in this case that the domain is goes all the way down to negative infinity, and it comes up to 7/3. Okay, is that the right? Nope, that's not the right notation on the interval. It can include 7/3, so it goes right up to and includes. So we put the square bracket on that. Okay. Another example. Let's suppose that we have the function and the numerator is x squared and the denominator is x squared plus x minus 6. There's nothing that can go wrong up here. X can be 0. You know, we can put a negative value in for x, square that, it's going to be positive. So once again, we're just looking at this denominator here. We've got to make sure that the denominator is never equal to 0. If we factor this, factoring the denominator gives us x plus 3 and x minus 2, because you're looking for factors of negative 6. So you know that one of them is going to be positive and the other one's negative. Factors of negative 6 that have a difference of 1, and so 3 and 2. So in this case, we can't allow either the x plus 3 to be equal to 0, nor can we allow the x minus 2 to be equal to 0. So in that case, what we're saying is x can't be negative 3 if we subtract 3 from both sides, and x cannot be a positive 2 if we add 2 to both sides. So that's the limit, that's the domain that we have on this particular function. Okay, one more, and I'm going to do that over here. Just got a little bit more room over here for this third one. There's a little more involved, but I think you'll get it. If we take the rational function here, and in the denominator is radical or square root x squared minus 2x minus 8. Again, don't worry about the numerator, that's just a constant, but down here we've got both. We've got the issue of we can't divide by 0, nor can we allow this to be negative. So let's first of all see what we get when we factor the polynomial that's under the radical. Looking for the factors of 8. One of them is going to be positive, the other one's going to be negative, that have a difference of 2. That's going to be 4 and 2. So that's going to be x minus 4 and x plus 2. Okay. Well, we certainly can't let x minus 4 be 0, nor can we allow x plus 2 to be equal to 0, because those are in the denominator. We've got to make sure that this is never equal to 0. So right away, if we just think about that for now, we know that x minus 4 can't be 0, so adding 4 to both sides, x can't be 4. And if x plus 2 can't be 0, then if we subtract 2 from both sides, we get x can't be equal to negative 2. However, there's something else going on here. We've got an even root in the denominator. And we've got to make sure that this product of x minus 4 and x plus 2, we've got to make sure that that's not negative. Well, the only way that this product's going to be negative is if one of them's negative and the other one's positive. So if we have to keep this product positive, then either they're both positive, either both pieces here, both of these factors are positive, or both of the factors are negative. Okay? Alright, so let's think about that. If we take, I'm just going to do some side work here. If we take the factors x minus 4 and x plus 2, and let's think about what would be required in order for both of these to be positive. Well, if both of them are positive, then that means x is going to have to be greater than 4, because as soon as x gets below 4, this becomes negative. Okay? So x has to be greater than 4, And the only way that this is going to be positive is if x stays up above, I guess it can be equal to 0. No, it can't be equal to 0 because I was just thinking it could be 0 and still take the root, but we've already said it can't be 0, so disregard that comment. What I was saying here was in order for both of these to be positive, x has to be greater than 4 and x has to be greater than -2. Well, if we're both positive, x has to be greater than 4 trumps x greater than -2. So in this case, x has to be greater than 4 if both of these are going to be positive. Okay? I don't know if you understood what I just said there. I said x greater than 4 trumps x greater than -2. Because if it's greater than -2, like -1, that doesn't satisfy this. 0, 1, 2, 3, those all satisfy x being greater than -2, but it also has to be, x also has to be greater than 4. So, x greater than 4, as long as x greater than 4, it satisfies both of these. Alright, let's look at this, let's consider this product again. The factors are x minus 4 and x plus 2. Now, we said the other way that we can ensure that this term under the radical is positive is that they're both negative. Okay? Now, how can x minus 4, for what values of x will x minus 4 be negative? Well, anytime x gets smaller than 4, anytime x gets down below 4, like 3 or 2 or 1, this difference is going to be negative. Now, on this side, how can we be sure that this is negative? Well, if it's greater than -2, it's going to be positive. So if it's less than -2, it's going to be negative. Now, look what's happening on the other side. In order for these to both be negative, here we said for this one, x has to be less than 4. For the second one, x has to be less than -2. Well, how can you satisfy both of these? You're certainly not going to satisfy the requirement that both of these are negative if x is 3 or if x is 2. X has to be less than -2 in order for both of these to be negative. So again, like I said before, in this case, x greater than 4 trumps the x greater than -2, and so the requirement for both of them to be positive is x greater than 4. Down here, x less than -2 is the requirement that for both of these to be negative. All right. Well, what have we seen here? First of all, we know that the denominator can't be equal to 0, so we know that x can't be 4 and x can't be -2. But we also know that you do not take an even root of a negative number. So in order for this product to be positive, either both of the factors are positive or both of the factors are negative. If both of the factors are positive, x is greater than 4. If both of the factors are negative, then x has to be less than -2. So we put all this together. The domain for this function is anything less than -2 along with, so we take the union along with all values of x greater than 4. Okay? Or you could write it this way. You could say x less than -2 and x greater than 4. Whichever you feel comfortable with. Show your work and I'll know what you mean if you write either one of those two ways. Okay, so there's 4 examples of how to make sure that you're limiting the domain to avoid using values of x that are either going to give you a 0 in the denominator or that are going to give you an even value under the radical. Pay attention to that, and hopefully that helps answer any questions you might have about domain.